Hello there. Welcome. Good afternoon, good morning, good evening to all. Thank you guys very much for taking time out of your day to join us to talk a little bit around Red Hat and Citrix. We're going to get started in just a moment. I think we'll get started perhaps a minute after, I guess 3 minutes after. While we're doing that, we're going to just go ahead and do some quick introductions for our speakers today. I'll start off. My name is John Gibson. I am a global ISV partner alliance leader here at Red Hat. I manage the partnership between Red Hat and Citrix and have the duty today to be the MC for today's discussion. We're joined by two fantastic speakers, Giri Venkatraman and Mayur Patel. Giri and Mayur, do you guys want to do just some quick introductions for yourself?
Sure thing, John. Thank you. Good morning, good afternoon, wherever you are, everyone. Giri Venkatraman, I'm Associate Principal Solutions Architect. I'm with the global ecosystem team here at Red Hat. I work with several of our ISV partners, Citrix being one of them, and I'm excited to be here, and thank you for taking the time. Mayur?
Thanks, Giri. Yeah. Hello, everyone. Greetings of the day. My name is Mayur Patil. I'm the lead product manager associated with Cloud Software Group, and I represent NetScaler Modern Apps Deployment. Happy to see you all here, and stay tuned for more updates on NetScaler Kubernetes Gateway API.
Awesome. Thank you, Mayur. Thank you, Giri. So just a little bit of housekeeping before we dive into, I just want to make sure everybody can hear us okay, and you guys can use some of the resources. So for those of you out there, can you please just put a couple comments, maybe where you're from, into the chat, some thumbs up, some emojis, if you guys can do that. I've highlighted it here for you just to make sure that you guys can see the chat. We will be using that as an area for discussions. And then also we will be using our Q&A here in the platform as well. So I've highlighted that as well. So for all of your questions, please make sure that you put them in the Q&A. We will have a section towards the end slotted specifically for Q&A for some of the questions, but we will also be answering some of them as we move along in today's presentation. So without further ado, let's go ahead and get this thing kicked off. So thank you again for joining us. Today we're going to actually be talking about from ingress to intelligence, NetScaler Kubernetes Gateway API for modern OpenShift workloads. As I mentioned, my name is John Gibson. I am the alliance manager between Red Hat and Citrix. I have the fortunate responsibility to be able to work closely with Citrix, my former employer as well, so didn't leave too far from the roost. But I get to work and design some of the strategy, integrations, speak and have conversations with customers around our joint integrations. So we're very excited to talk a little bit around Gateway API specifically for OpenShift. As I mentioned, I'm joined by Giri and Mayur, two phenomenal speakers that are going to walk us through everything today. But just to give you an idea around what we're going to be talking about, we're going to be talking a little bit of an overview around NetScaler and OpenShift, making sure that you guys are familiar with that, establishing a baseline of your knowledge. We're going to go into the actual integration itself, and then dive in directly into the Gateway API. We are going to have a demo that talks a little bit around the Ingress and Gateway API functionality and the NetScaler Kubernetes Gateway Controller. And as I mentioned, we will have a Q&A and some resources for you guys to be able to take advantage of towards the end. We will be sending this deck out as an afterwards, as a follow-up to everybody. So do not fret if you see something in here, or if you want to refer back to something in the slides, you will have that ability after we wrap everything up for today. So to just start out with a Gartner quote, I like to do these on some of these events just to make sure people understand why is it that we're building these integrations together with our ecosystem, because the ecosystem is incredibly important to Red Hat and obviously very important to Citrix as well. And so Gartner shares that by 2027, more than 90% of global organizations will be running containerized applications in production, which is a significant increase from fewer than 45% in 2022. So as you can see, containerized applications are going to be more of the norm as we move forward. And we've seen this in the market, and we've seen this, and we want to make sure that our partner ecosystem and fantastic partners like Citrix are ensuring that the best of breed integrations are there for our customers to consume. To amplify this, not just from a statistic, but also from Gartner as well, Red Hat OpenShift has actually been named leader in the 2025 Gartner Magic Quadrant for container management, a third year in the row. And then also in a recent 2025 Gartner Magic Quadrant for cloud native application platforms as a leader as well. So it's not just me saying this, it's the actual market itself and analysts that go along with it. We definitely see here from a Red Hat perspective as containers is the future, and we need our partners to be able to help make sure that we are successful in that as well. So without further ado, Giri, you're going to be our first speaker today to be able to talk through a little bit around OpenShift. What is this? And I'll pass the mic over to you.
Hey, thank you, John. John talked a little bit about the Gartner Magic Quadrant, and this picture here really solidifies why that is the case for Red Hat and Red Hat's OpenShift platform. What you see in this visual is really the two underpinnings of those Gartner Magic Quadrants, the container platform and application platform right in the middle. And what you see on the sides, are the virtualization platform and AI platform. And these are something that are emerging as part of our offerings and over the last couple of years from Red Hat. And we would like to talk a little bit about that because this has direct relevance to how we are going to be partnering with Citrix and NetScaler going forward for our joint customers to take advantage of these offerings. So again, the three pillars around which the Red Hat OpenShift platform has been built today, and which is why it's trusted by thousands of customers globally, is trusted, comprehensive, and consistent. So really what our customers are looking to do is to mitigate risk, to increase their productivity, and in doing so, being also flexible with the way they do it. And so there's a few reasons why Red Hat OpenShift is primed to do that. So the first thing we're going to look at is a little bit more double clicking into what Red Hat OpenShift is actually. So you see the secure Linux operating system that has been around for decades now, where Red Hat has built their reputation on a secure, stable platform on which Red Hat OpenShift is built. You see the layering on top of that, which offers the basic Kubernetes platform operations. And not just that, you'll see a couple of things here. You'll see on the left, running containers and virtual machines, which is what the basic Kubernetes platform offering does. But in addition to that, if you look on the right-hand side, you will also see the OpenShift Virtualization engine that's been introduced as a separate offering. And that is for our customers who want to run virtual machines only today, but then this also has a pathway to modernize into the Red Hat OpenShift platform. And so what you see on top of those are really the foundational application platform capabilities that provide you with the build, test, deploy capabilities, observability capabilities, and these are core things that our customers need when they're deploying and managing applications. And so on top of that, we offer a few other things like the Advanced Developer Suite, and you see OpenShift Platform Plus that includes our advanced management security piece. And then to top it all off, we have Red Hat AI, and we'll dive a little bit into that just to give you a peek. And also Red Hat Application Foundations, that is an opinionated offering from Red Hat to help you as customers deploy these applications. So with that, let's dive a little bit more deeper into what this virtualization capability is. So Red Hat OpenShift Virtualization has really been, again, built upon that platform of Red Hat OpenShift and is available in a variety of flavors, as you see there, the virtualization engine, Kubernetes engine, container platform, and Platform Plus. But more importantly, what it offers our customers is the capability to run virtual machines and containers on a single platform and being able to manage those seamlessly. And as you'll see towards the end of this, as we look at what is next for Citrix and Red Hat, you will see Red Hat OpenShift Virtualization coming into the picture. So the last thing I want to talk about before I turn things over is to dive a little bit deeper into Red Hat OpenShift AI. And really, this is, again, as you see, built upon Red Hat OpenShift. And again, it offers a AI ML platform where you can do all the things as a customer that are needed to build, train, and deploy your models. And this includes LLMs. And so a couple of the things that, exciting things that Red Hat is bringing out with its upcoming release of Red Hat OpenShift AI are things like, agentic AI capabilities, for example, and other things. And so the reason I'm mentioning all these things is because what we are going to do next is really talk about Citrix and NetScaler. And as this conversation progresses, you will see why the combination of NetScaler with Red Hat is going to be important to have a critical entry point that is secure and can manage the traffic to all of these diverse workloads that happen, your legacy application workloads on OpenShift, your virtual workloads, as well as your AI workloads. And so with that, I am going to turn it over to my friend Mayur from Citrix. Mayur?
Yeah, thanks, Giri. That was really a great introduction on platform of OpenShift. Now, let me give the overview of NetScaler for OpenShift. With that, hello everyone. Again, my name is Mayur Patil, the lead product manager at Cloud Software Group, representing NetScaler Cloud Native Deployments. Following Giri's OpenShift platform update, I will discuss NetScaler's strategic partnership and integration with OpenShift, ensuring a smooth customer transition with NetScaler as their Ingress or Gateway API proxy. We will cover a NetScaler overview, a cloud native deployment, Gateway API implementation on OpenShift, followed by a good demo. So OpenShift has made containers the default and adoption is accelerating. That's great for feature velocity, but it's put real strain on networking. So what has really changed over the years? First, our apps are distributed by default, meaning multiple clusters, multiple clouds, sometimes edges. The traffic paths aren't linear anymore, so a single change can ripple across the environment. Second, there are more owners. Developers are defining routes, platform teams runs the clusters, and security enforces the policy. Each controls part of the path, which means more hands-off and more opportunity for a drift. Third, the cadence is faster. We are doing blue, green, and canary every day. Networking has to keep pace with app changes, not the git them. Finally, the team expect OpenShift native patterns. They want to use Kubernetes construct, Ingress today, newer models when ready. And they want everything into CI/CD pipeline. So as a result, all of this shows up as a friction or toil. The networking work becomes tickets and copy-paste configs across the clusters. Simple updates slows down because 3 teams needs to coordinate. We also see risk exposure. When definitions lives in different places, policies drift. Visibility is patchy end-to-end. So troubleshooting and audits takes longer and incidents last longer. And there is a cost leakage also. To be safe, we over-provision and east-west becomes shattery. And sometimes this noisy ingress drives the cloud cost. Then why this matters now to us? As more of the portfolio moves onto the OpenShift and the containerized workloads becomes the norm, the gap between app speed and networking operations only going to widen. If we don't address it, release slow, and attack surface expand, speeds creeps up. So what is the solution for this problem? NetScaler and OpenShift is the solution for speed, safety, and saving without extra complexity. Let's talk about the 3 pillars, which will help you in shipping faster, reducing the risk, and spend less. First, ship faster. Teams define traffic with Kubernetes native constructs, like we discussed, either Ingress or maybe the Gateway API in future. The OpenShift operators handle deployments, lifecycle, and day-to operations. So changes move through the CI/CD pipeline instead of tickets. For brownfield deployment, our config to infrastructure as a code tool converts existing ADC polys into Terraform or Ansible, standardizing changes and rollbacks. How do we reduce the risk? We enforce one policy model across the clusters and clouds with end-to-end observability so drift is visible and auditable. Enterprise protections such as WAF, API security, AAA, mutual TLS are applied consistently, all managed through a single console and API with a role separation, logs, and compliance-friendly reporting. The spendless. The single pass data plane means fewer hops and boxes, which consolidate points tools and avoids duplicate capacity. NetScaler is Application Delivery Controller, also known as ADC, available in multiple form factors, allowing organizations to deploy the same software and features across various environments. This architectural approach builds on the single code base, provides operational consistency and flexibility. On top of that, all these form factors are managed by a single unified platform called as NetScaler Console. NetScaler one-pass architecture is a unique design that allows device to perform multiple complex functions on a single packet as it moves through the system. By eliminating the overhead of passing data between the different processing engine, NetScaler can handle much larger volume of requests with low latency, which is critical for modern and high traffic web applications. We also offer single unified licensing for all the NetScaler appliances deployed across hybrid multi-cloud environments. NetScaler robust one-pass architecture and unified code base have established it as a leader in traditional or monolith application delivery. However, with industry shift from monolith to microservices architecture since maybe early 2015, OpenShift emerged as a key enterprise-grade Kubernetes distribution for managing container deployments. This transition led customers to evaluate NetScaler for microservices application delivery, allowing existing NetScalers users to leverage their current NetScaler appliances for newer microservices workload on the Kubernetes platform. As you can see in the topology diagram, how the traditional versus microservices application deployment looks like. So you can see the existing NetScalers can also be leveraged for now microservices application delivery without impacting your existing workload, which is your traditional applications. Our solution secures microservices applications across on-prem or cloud Kubernetes. NetScaler extends its features to microservices, offering layer 7 traffic management, which includes load balancing, TLS offload, end-to-end TLS, or content routing. We also offer GSLB or multi-cluster ingress for high ability resiliency of your applications. We do support application or API protection through WAF, BOD, AAA, or rate limiting. NetScaler also ensures that cluster stability by load balancing master node management plane traffic, meaning that if you have a multi-master node deployment, you can place NetScaler in front of them for load balancing the management traffic, which will ensure that your clusters are highly available at any point of time. Let's dive deep into NetScaler Kubernetes Gateway API implementation. I hope you are excited now. Before delving into Kubernetes Gateway API, it's essential to grasp the concept of the Kubernetes Ingress. Kubernetes Ingress serves as a single entry point for external traffic into the Kubernetes cluster facilitated by a proxy. It offers various rules, annotations, and settings for intelligent routing decisions. Each Ingress proxy vendor is responsible for implementing its own logic to support Kubernetes Ingress. For instance, NetScaler provides NetScaler Ingress Controller, which is deployed within the Kubernetes cluster and integrates with the NetScaler to automate traffic management configuration. As you can see on the right hand side, here is the sample ingress manifest file, which has important environment variables or the sections, like you have to mention what is the ingress class, what is the TLS section, which will allow you to create the host and host details and the TLS example. Then there is a rule section, which also includes what is your host and the backend configuration, which is nothing but your applications. In the gray boxes, you can see some acronyms mentioned. All these are the NetScaler entities which are created by this specific block of this manifest file. If you are not familiar with the NetScaler and hearing for a first time this terminology, stay tuned. We will also show you this particular example into demo where you will understand what is content switching vServer, what is SSL vServer, service group and all. Following the conversation on the Gateway API, now let's see the Kubernetes Gateway API overview. The Kubernetes Gateway API evolved due to the limitations within the Ingress API. While Ingress is suitable for basic routing, advanced routing often relies on the proxy vendor-specific custom annotation. A significant challenge with the Ingress also lies in a unclear ownership between platform administrator and developers. It is always a challenge between who will own the Ingress configuration, whether the platform team or the developers. And to solve that problem, we have a Gateway API solution. Let's see how that helps. To address this issue, Kubernetes introduced the role-oriented Gateway API solution. This API model establishes clear ownership among the three distinct personas. Let's talk about them one by one. First is infrastructure provider, who owns the gateway class resources. We will also see how the gateway class resource look like in the demo. And then second persona is the cluster operator, who are responsible for managing the clusters, managing the gateway resources. And the third is the application developer, who owns the route resources. And there are multiple routes, as you can see, created by the community, starting with HTTP route, TLS route, TCP route, gRPC route. We would focus more on the HTTP route for today's demonstration. But as and when this community is going to add more and more routes, application developer would have choice to write their own route resources. Now you would be wondering, I have talked about Ingress, I have talked about Gateway API, but if I have to put both together in one slide, can you help me with that? So here is the one slide that can help you to understand why Gateway API is gaining more popularity and have advantage over the Ingress. So I have tried to list down multiple pointers through which you can identify why Gateway API is becoming more popular and the successor of Ingress. So as you can see, the protocol support, typically Ingress having HTTP or HTTPS support, but for non-L7 support of for non-support of protocols which are not HTTP and HTTPS, you would have to depend on the proxy. As I was mentioning earlier, proxy has to implement its own annotations and its settings for supporting non-L7 protocols. On the other hand, in Gateway API, the community has given the option for creating L4 or L7 protocol support natively. When it comes to the traffic management, Ingress is good for basic routing, but what if you need little more advanced routing, such as you need traffic splitting, mirroring, traffic injection, simplified canary, blue-green? All these use cases are simplified by the Gateway API. The portability is very key important features and functionality that Gateway API offers, which we would have seen that it has now standardized the deployment, where in Ingress you had to depend on the different vendors to create that. So that complexity of creating those resources has been abstracted by the community, and you have a unified deployment option. The resource objects, like you have seen, Ingress was the one object which was kind of a becoming challenge for different personas to be created, whereas in the Gateway API, now there are three owners having the three different entities to be created, managed by the three different personas. Like I mentioned in the traffic management, advanced traffic management is simplified in the Gateway API. Similarly, routing rules are also simplified in the Gateway API. Last but not least, extending the capabilities. There are multiple capabilities that Gateway API has been adding in it. For example, authentication, rate limiting, HTTP to HTTPS redirect, header modification. All this used to be the kind of a vendor CRDs, custom resource definition, earlier in the Ingress. Now that has been embedded into the Gateway API implementation. And this all we will see in the demo, which is coming up shortly. Now also, if I have to put an example for you to map between Ingress and the Gateway API, here is one quick example where you can see on the left-hand side, there is an Ingress manifest file. Like I was mentioning earlier, it has the standard template to be followed for creating the front end of the proxy, creating the back end of the proxy, creating the TLS section. So if you have to map to the Gateway API implementation, you would mainly need three entities which are will owned by the three different personas. First is a gateway class where you would mention the controller name, like the NetScaler is having the NetScaler Kubernetes Gateway API controller. While deploying that, we have to ensure that the gateway class is matching with that name. It's the functionality wise, Ingress also had the Ingress class name that has to be matched. That they have simplified and created a separate manifest file for that. The gateway, it's a crucial piece for creating the front-end entity of the proxy, meaning that here you would mention that what is the TLS section, meaning that whether I need a SSL in the front, then I need to provide the TLS section with a mode terminate, and I will also have to provide the secret information. And in the listener, I will mention that what are the different protocols that I want to load balance, HTTP, HTTPS, TCP, so on and so forth. And then comes the HTTP route, which takes the logic of the backend of the proxy or the NetScaler, where you would define the application details. What is my application, on which path I need to expose, what is the port for which I should expose that, what is the host name, how do I access that from the internet. All those capabilities we would add into the HTTP route. And if you notice, there is a link between gateway class, gateway, and HTTP route by the parent ref. So this is what I tried to get it for you. I believe community is also writing Ingress to Gateway a tool. There is one GitHub link already available which helps you to do that migration, but it will take some time. So this type of example for now would help you to simplify what is the difference and how should I write the Gateway API. This is another example for little more complex Ingress deployment, where if multiple applications are sharing the front end or the external proxy resources, then the typical Ingress would look like this, where you would have two different host section like foo.example.com and bar.example.com. So these two different applications would be hosted under single front end web. If you have to translate that, it would convert into multiple files. I have just skipped the gateway class, but it would be there. The gateway class would be there. There would be the gateway, which would have two different listeners for both the applications. And now you have to create two different HTTP routes. One for first section, the foo.example.com, and another for this bar.example.com. And also on top of that, if you need to do some more advanced traffic routing, such as HTTP to HTTPS redirect or header modification, you would take same HTTP route and add some filters on top of that. All I will show in the demo, which is coming up shortly. So idea is that in this to the example, I wanted to show that how the mapping is happening, and I'm sure that we will have some automation coming up soon in the industry. So before jumping into the demo, if I have to summarize what we offer for you, so this NetScaler Kubernetes Gateway Controller has been introduced to automate Gateway API configuration on the NetScaler. Similar to NetScaler Ingress Controller, minimum one of the NetScaler Kubernetes Gateway Controller is required per Kubernetes cluster. Our latest release, version 1.1.0, offers TLS offload, HTTP filtering for advanced L7 traffic management. A demonstration will illustrate its functionality. As Gateway API gains popularity, the community continues to add new capabilities. We are actively incorporating this into NetScaler Kubernetes Gateway Controller. With recent roadmap, including TCP routing, NetScaler protocol profile support, and IPAM support for IP address management is planned in a short while. Now here comes the magic. We will go into the demo section and I will demonstrate what I have been talking so far. So let's see what we are going to demonstrate today. So for demonstration, I have created the sample topology diagram. As you can see, we are going to use the NetScaler VPX, which will be deployed in front of OpenShift cluster. And in OpenShift cluster, we are going to have two different applications running and getting load balance through the NetScaler. To show the different use cases, I will start with first showing how NetScaler does the load balancing for your application using SSL offload. Then we will see some security specific use cases which are very important nowadays, starting with HTTPS reinforcement, where our companies like enterprise customers are nowadays denying HTTP request and or enforcing HTTP to HTTPS. As I was mentioning, this is one of the default functionality Gateway API is offering. Let's see how we do that. Another example would be URL beautification or canonical URL enforcements. So this is also, again, if you want to add some security or compliance headers, how shall we do that? Followed by some two more use cases which are associated with NetScaler rate limiting and NetScaler responder policy, which is allowing only trusted clients to access the application, and granular API throttling. So let's go over into the demo and see all this into real world. Let me share my screen to bring up the demo. Perfect. So I hope you are able to see my demo screen, and let me just start the details. So here is my CLI where I'm just showing the OpenShift version and the OpenShift nodes. I have a 3-node cluster. Here is my OpenShift console. To start the deployment, let's go to Operator Hub, search for NetScaler. You would see that NetScaler operator exists there. I already installed the operator for you. And once you go to the install operator, you will see that there are multiple options to deploy different products of NetScaler, which is managed under one NetScaler operator. Let's go ahead and do the Kubernetes Gateway API deployment. I just want to highlight a few changes which are important to be done while creating this manifest file. Yeah.
Sorry, I think the demo screen is not visible.
Is it?
Yeah, I cannot see the demo screen.
John, can you confirm?
This is Giri. I am able to see the demo screen. Okay.
Oh, okay. I'm sorry.
That's okay.
I'm not able to see. Thank you.
Okay. Maybe in the chat, somebody else can also confirm if you're not.
We have folks that can't see the demo.
Jan has confirmed. Thanks, Jan. So yeah, so let me continue the demonstration. So as I was mentioning, this is the configuration that has to be created. Some changes like the Gateway API. Let me go back to just show you the important messaging. So once you go and create the manifest file, I'm just copying it for showing the reference of what are important fields. So first is definitely the NetScaler IP, the management IP, and its credentials. It's important to connect from the OpenShift cluster. Also, we have to ensure that we provide the prefix, which is any name, and the gateway controller name. This is important, which would be mapped to the gateway class. Now let's do the status check of this deployment. Going to the workload deployment, you would see that there is one pod running for the NetScaler Gateway API controller, and you can same check with OCGate pods. Now the controller is running. Let's see the gateway class configuration. So here comes our infrastructure provider who is responsible for creating the gateway class. This is the typical gateway class look like, where you have a name of the gateway class and the controller name. So this controller name has to match with your controller, which I was mentioning in the NetScaler controller. So let's go ahead and ask infrastructure owner to create the gateway class. As soon as you create, you see some message that it has been created. Now comes the ownership of the cluster admin. So cluster admin comes, it creates the gateway resource. And in this gateway resource, a few things to note. We have to mention the gateway class name, which is available in the gateway class, and also you have to mention the IP addresses. So this IP is the one of the free IP that you will use on the NetScaler as a front-end IP. And in the listener section, I was mentioning, like, if you have a multiple protocols, HTTP, HTTPS, to be allowed for doing the load balancing or allowing the traffic for your application, you can list down. If you don't want HTTP, just remove this section and just keep HTTPS. And if you have HTTPS, then TLS section is mandatory, where the certificate name, which is SSL certificate NetScaler-demo, coming from OpenShift cluster as a secret, will be pushed from the OpenShift cluster by our controller to the NetScaler. So let's see, once we proceed, how it happens. I'm just showing that this is the .81 is my NetScaler, where no information is available on the NetScaler. As I was mentioning, I am going to show one by one what this configuration brings onto the NetScaler. Once you create this gateway instance, you would see that content switching vServer is getting created with the IP 116. So this is the front-end IP for accessing your all the applications behind the this IP. Now comes the developer. Now developer is responsible for writing the HTTP routes. So in HTTP route, we have to provide the parent ref, which is your gateway. And you also have to mention the rules, like what is my application, what is my host name on which I will be accessing the application. Let's go ahead and do the deployment. Now, here comes the additional incremental configuration on the NetScaler, like we will create the content switching policy, load balancing server, and you can see it is down. The one of the reason for it is down because NetScaler having the health monitor to check whether backend application is up or down. So far, developer has not created any application. Hence, our monitors are saying that application doesn't exist and the status becomes down. So now let's go ahead and do the CNN website configuration. So once we create this application, you would see that we are creating the two instances of CNN website. And once we go back to the NetScaler, now you can see there are two pods running. Here, once you come back, you would see that the NetScaler virtual vServer is up, and just going to the members, you can note down that these are the two IPs, which are nothing but pod IPs of the CNN website. Just to reconfirm, .73 and .214 are the pod IPs, which are actually getting populated in the NetScaler. What does it really means? When NetScaler is sending the traffic from front end to the back end, it is actually sending traffic directly to the pod IP. No queue proxy and other proxies coming into the picture, which also reduces the latency, because now we have a full control on the pod network, if provided we have a connectivity between the NetScaler OpenShift, and this can be played. There are other options also. If you don't have a connectivity, we have other solution. But for demonstration, I'm showing that there is a way for connecting with the pod network. So now let's go ahead and do the deployment. I'm just testing the HTTP application. I'm now doing HTTPS application testing. You would see that application still is not available. Can you guess what would be the reason? So as I was mentioning in the TLS section of the gateway, you have to mention the secret, which is nothing but SSL certificate. So infrastructure team and the Kubernetes cluster guy has to ensure that this secret exists, which we are going to create now. As soon as you see that TLS secret has been created, NetScaler will quickly update the NetScaler with the SSL configuration, and you will see that application over SSL is working now. You can see the changes, right? How fast it is happening. It's just like in few seconds, not even seconds, it is just getting populated on the NetScaler. That shows the magic of our integration with OpenShift and NetScaler acting as a proxy for OpenShift workloads. Now, if the Kubernetes admin, the platform admin, has to onboard another team, another development team, so we have to create another HTTP route. So this is one example where I want to demonstrate how we are onboarding the guestbook application team. For that, developer would write HTTP route with its host name and the backend reference. So now let's go ahead and do the deployment of the HTTP route for this guestbook application. Along with that, we will do the deployment of the actual application. This is a sample guestbook application, which is widely available on the internet. You go take it up and do the deployment. But now let's go back to the NetScaler and see the status. So you can see the guestbook application is up and running. I will test whether it is up and down. Both are up because our monitors are up. Reason being, application also exists. So I'm just quickly testing if whether the Redis backend is also working or not. Yeah. So stay tuned. We still have more use cases to be covered. Now let's go into the security use cases. First is this HTTP to HTTPS redirect. So HTTPS enforcement. As I was mentioning earlier, that Gateway API is providing the default option for doing such type of configuration, which is nothing but HTTP to HTTPS enforcement. So how it would look into the file. So this is the one sample file HTTP route, in which you have to mention that what is my parent ref. This is the gateway reference that you have to mention, and the section name. So I want to apply this on the HTTP section of that listener, where my filter says, you have to give all these details into the filter that I want to do the request redirect, and with the status code 301. Now, once we have this all successfully created, go ahead and do the deployment. You would see that it has something has happened in the background. What has really happened? So you could have seen HTTP is now getting converted to HTTPS. On NetScaler, let's see what are the changes happened. On the content switching vServer for HTTP vServer, you would see that there is one request policy. So this policy suggests that you have to do the 301 redirect, and it will be redirected to HTTPS. So that was first use case. Now let's see the header modification or header insertion. First, we will dive deep into the URL redirect or URL rewrite. So this is one sample example. As you can see, I have now mentioned the specific host name and the specific URL and the specific backend reference, which is CNN website, on which I want to use this URL rewrite capability. What will eventually happen with this replace prefix match? I am going to forward all the /URI traffic to /v2, right? Just now, let's see how it's going to happen. So this is the file. This is actually application. I'm just also showing that v1 and /v2 application. You would have noticed that there is a slight change in the color between the / and v2 application. Once I go, I'm just again showing you the manifest file to ensure that this is the exact application on which we are going to apply /v2 changes. So I will now apply it into my OpenShift cluster. And once I get a success message, I will now just try to do cloud native application access, and you would have seen that /application is now accessible. Also, let's see in the NetScaler what has really changed. So in the rewrite policy, you would see that one rewrite policy has been added, which says that just change the URL to /v2. Now moving to the third use case, where I just want to ensure that how we do the header insertion. I just want to show that for the guestbook application, there is no client IP and demo header already available. So if I have to add some compliance or security header, how would I do that? So we have an option for adding the headers either on the request side of the traffic or on the response side, which you have to mention in the filters. And like you can see, there are two headers that we are going to add on the response side. Let's go ahead and create this manifest file. After successfully applying it, I am going to refresh this application, and I'm just going to inspect the traffic. As you can see, in the response header, the client IP and demo has been added, which we have instructed from the OpenShift cluster. Again, we can go to the NetScaler and see what are the changes has been added into the NetScaler. So we have added 2 rewrite policies associated with 2 actions for adding 2 headers. So that was a quick update on the how we can do the header modification or header rewrite. Now, going to the next 2 use cases, I first want to help you to understand what is this extension ref. So as I was mentioning earlier, NetScaler has its own rate limiting, own WAF, own rewrite responder. So to leverage those CRDs, custom resource definitions, which we have already supported for the Ingress controller, if we have to bring those for the Gateway API, we have to create this extension ref. How does that look? It is part of the HTTP route where you will mention what is that application for which I need that. And in the filter, you would mention type as extension ref, and you will create a block of what are those kinds like rewrite policy and rate limiting, which you want to be applied for the Gateway API. And then just take a note of these 2 names, blacklist URL and the throttle the request per client IP. So these names we would be using in the examples for demonstrating these 2 use cases. So first, let's go ahead and create an extension ref for adding the NetScaler custom resource definition. And now let's see one sample example of how do I want to block my client IP for accessing /URL and /password URL. As you can see in the pad set, I have mentioned that what are the URI on which I want to block my IP address. So this is a typical rewrite policy that you would have seen we would have used in the Ingress deployment that we also want to now apply on the Gateway API configuration. Once you do that, you would see that I am not authorized to access that. And also, if you notice, .password was also there as one of the URI. If I try to access that, I'm not able to access because the policy has been set, responder policy has been set, saying that you are not allowed to access these 2 particular URI. And this is the custom response that we can send. Now, let me delete this again to show that I'm able to access both the applications, and it is happening in almost in the real time. Now the .password is also showing up. This is the last use case where I want to demonstrate how we can do the rate limiting through the Gateway API. Let's say if you want to avoid a DOS attack, or if you want to limit the incoming request for your application, rate limiting is one of that policy helps you to do and mitigate such type of threats. So what we are doing here, we are adding the rate limiting where we are just going to allow 2 requests in 60,000 milliseconds. For demonstration, I have kept that buffer very high of not allowing many requests. So once I create that, what is really going to happen? I'm just going to get allowed for accessing this application twice. From 3rd request onwards, I'm going to get the 429 HTTP error. Reason being, on the NetScaler, the rate limiting policy has been added by the Gateway API controller, which says what is the configuration that you would have seen in the manifest file. And there are hits which says that, okay, application is in action. If I delete this rate limiting policy again and try to access application more than 2 times, you would see that I have access because rate limiting policy has been removed. So these are all the demos I just wanted to cover as part of the Gateway API implementation. As you would have noticed, this is a really quick demonstration of the use cases which we have started supporting. And I was also mentioning that there is a big roadmap which is coming up for you. So stay tuned. I'm excited to share more updates as and when we progress with the Gateway API implementation. With that, I would like to invite John again for further updates.
Awesome. Thank you, Mayur. Awesome demonstration. Thank you for walking us through that. Thank you, Gary, also for the overview of OpenShift. So let's bring it back. I know we have about 9 minutes left, so thank you guys for holding on out there. I know we have a couple questions in the chat. We'll get to those in just a second, but I just want to wrap up. Make sure to point you guys to some resources. But hopefully after today's presentation, you've seen, obviously, there's a lot of technical integration work that's behind the scenes between Citrix and Red Hat. And it really takes an entire slew of people to be able to ensure that these integrations work for you all in your environments. So this is actually a third part in a series of webinars that we've done between Citrix and Red Hat, specifically on the NetScaler side. So as we get these slides over to you, we highly encourage that if you have not seen the past couple webinars, to please go in and check them out. The initial one that we did was around high performance and secure ingress with NetScaler for OpenShift applications. The second one that we did was scaling and protecting Red Hat OpenShift deployments for NetScaler. And then obviously this one today. And this is just the first of many in a series that we are going to be doing for you all. So I'm going to talk a little bit around like what's on the roadmap, teasing out a couple things for you guys for what's coming over the next, I'd say next year or so. So if you guys haven't seen any of the news between Citrix and Red Hat, in addition to the Gateway API functionality, Citrix has also come out with support for virtual apps and desktop support for OpenShift Virtualization in the mid-August timeframe. So if you're not familiar with that, Gary had done a quick overview around OpenShift Virtualization earlier in the discussion today. Now you're able to actually run Citrix virtual apps and desktops, so your VDI workloads on OpenShift Virtualization, just furthering the commitment and support from the Citrix and the Red Hat side. Red Hat OpenShift AI launch 3.0 is coming out in October, which I don't want to spill too much out there, but obviously there might be some interesting things coming down the pike from both the Citrix and a Red Hat perspective. Last but not least, end-to-end SSL TCP routing, gRPC routing, and NetScaler Gateway API implementation, continuing further the integration there. So just a couple things to be expected as we continue this partnership and relationship moving forward. And with that being said, we've got a slew of resources for you all to take advantage of. We'll get you guys, again, these links to everything here. If you're interested in learning a little bit more, you've got the links to the webinars. If there's maybe you want to get your hands on a little bit more, there are links there to the trials themselves, so you can get engaged with OpenShift and then also get engaged with the NetScaler side. And then obviously there's how-to guides around how to deploy a lot of this stuff. So if you guys do have any questions, obviously you can reach out to your respective account teams to get additional information, or if there's any questions, concerns, please feel free to reach out. And without further ado, let's go into the Q&A. So I know we have a couple questions. There's a couple that I want to get just kicked off really quick. And so if you'll give me 1 second, let me just scroll down. Here we go. So let's start off with a question in here. Can we use NetScaler with Rosa? Gary, I'm going to pass this one over to you, but just to level set and make sure everybody's on the same page for those that might not be familiar with Rosa. Rosa is Red Hat OpenShift service for AWS. It is a managed service offering that is offered through the AWS marketplace, where AWS is offering initial first-line support, but you can run essentially OpenShift inside your AWS environment. Gary, maybe you want to take that one first?
Sure. So like John mentioned, right, Rosa is a first-class citizen on AWS, and it's a turnkey application platform. And so a lot of our customers use that for to start delivering on their applications to their lines of business in a much faster, secure way. And NetScaler can be used with Rosa just as it can with an on-premise OpenShift cluster, for example. And so you can, a couple of options there. You can front that with NetScaler VPX, for example, that may live outside the cluster and manage things that way, or have, like Mayur demonstrated as part of this, have a containerized version, using OpenShift-based operators, right, and deployed within the OpenShift cluster itself. So you do have options, and I don't know, Mayur, if there's anything to add in terms of the various form factors, that NetScaler offers, but I'm sure a lot of those can be accommodated as well. So.
Yeah, you have covered all those pieces. Just to add a bit more, as it is on the cloud, we would use the VPX on AWS front-ended for the Rosa offering. And we do have customers already using that. So it is well-tested solution. And that's the reason we both are there for you as showing this joint webinar.
Excellent. Thanks, Mayur. Thanks, Gary. Mayur, a question for you from the Q&A. Is it possible to combine an upstream NetScaler, like the VPX in the demo, with a CPX within Kubernetes through the gateway controller?
Yes, there is no constraint for not using CPX. We have that flexibility for using CPX along with Gateway API. So what we are doing, we are working on supporting CPX through the Gateway API. At the moment, customer has to use the Ingress piece for the CPX, and VPX can be used with the Gateway API. And we are bringing this Gateway API controller capability to the CPX also very soon.
Excellent. Awesome. Thank you very much, Mayur. Let's talk a little bit. Can we share the videos to review the use cases? Yes, absolutely. I believe in the webinar or in the slides, there will be a potential video for you guys to be able to access that. Obviously, I think the recording will also be available for this as well afterwards. So you will be able to review those use cases. I see a question in the chat around licensing and Git repos. Munir, if you wouldn't mind, is there a specific question around licensing, or Mayur, maybe you want to talk about licensing in general for Gateway API?
Yeah.
Sure.
So yeah, regarding the licenses for the NetScaler, as I was mentioning, we have unified licenses offered, which runs across the multiple form factor. So there is no extra licenses required for running the Gateway API controller. More specific, the NetScaler Kubernetes Gateway API controller is free of cost. You just have to go to the repository and do the hem chart, or maybe you can go to operator and download that. There is no licenses required. You would need licenses on the NetScaler because that's the data plane. The Gateway API or the Ingress controller are the control plane traffic, which is absolutely free.
Excellent. All right, and just the last question that we're going to take, because I see we're coming up here on time. Mayur, this one's going to be for you as well. Would the end user experience change with the Gateway API deployment?
No, absolutely not. This is just the benefit that is being offered for the three personas which I was mentioning earlier. But for end user, the traffic flow remains same, whether it is the Ingress deployment or Gateway API. So end user don't have to bother much. It is the simplicity that has been provided for the infrastructure owner, cluster admin, and the developers.
Excellent. Thank you very much. So with that, I think that concludes our time for today. John, I see your comment in there regarding a webinar in Spanish. I'd recommend getting connected with Komal and Mayur from the Citrix side if you're interested in doing something there. We're happy to help support that wherever we can. For the rest of the folks here for today, thank you guys very much for taking the time to spend an hour with us. We very much appreciate it. We know your time is valuable, so thank you. We hope we can see you guys on our next iteration of these webinars. And thank you again. Hope you have a fantastic day.
Thanks for your time.
Thank you, Gary. Thank you, Mayur. Thanks, guys.
Thank you.